Thank you very much for coming today, guys. It's a great turnout. I know it's a big commitment to take a whole day out of your time and come along, and hopefully we're adding value so far this morning, and we'll continue to do so. My job today has been tasked with taking you down into the data center part of the sessions and really drilling down to that next level of detail. Presentation title this morning is Data Centers in the Cloud at the Edge, Where Next? So we're going to start with a little bit of a year in review. I like to clip the news and put it into Evernote when I see something interesting, and I have those little data center Google AdWords things set up, and you get a lot of interesting stuff through that, and I try and read it once a week to keep myself informed. I've got quite a lot of little clippings that I want to show you, which I think shape where the market's going, and particularly the Australian landscape at the moment. I've also got some good market analyst data from around the world and locally in Australia. I get lots of reports through our market intelligence people, so I'm going to try and boil that down onto one slide for you, hopefully add some value around that. And then we've got some research to take you through, some research that Trevor did with us before Christmas, and also some 451 group data there as well. I'm going to pose you to start thinking a little bit differently about availability. All right, so I'm going to take you on a little bit of a journey around why I think we need to start doing that and why Schneider thinks we need to start thinking a little bit differently. I'll go into the data center innovation at every level story, so drilling down from where Joe got to, and then I'm going to give you a small entree of some of the offers that we have that we are launching, some of which are outside here. And this is actually a really dynamic environment out there. So there's decent live demos, particularly it's the first time we've ever brought a live UPS showing the latest in technology to an event like this. So please swing by and have a look at that as well. All right, so the last year in review. Executive summary, data center market is buoyant but has its challenges. A lot of talk about edge computing, and we saw this little one. It's not the headline that's interesting down the bottom there, but it's really what he says underneath. We interrupt your regularly scheduled migration to the cloud to bring you a much more important trend called the Internet of Things. So a lot happening in that space, a lot of discussion around edge compute and what that means, and I'll talk you through some of that a little bit as well. Mark Thiel, who was, I think, the CTO of SuperNAP, which is one of the largest data center providers in the US, wrote a paper and he said, if we get these 50 billion connected things by 2020, we're actually going to need 400 million new servers to actually be able to process and deal with all that data. Right? So that is a significant phenomenon. That's about twice what we currently have at the moment. He estimated 400 million servers in the world as it stands today. We're seeing a lot more cognitive computing and a lot more of artificial intelligence and things come into play. IBM Watson, I was fortunate enough to see that in the US in action and meet the people behind it. Fantastic piece of equipment, and I really think that it'll revolutionise many industries, that type of thing. Locally, we are seeing things like a rise of regional data centres. And as Steve said, power's a bit of a challenge in Australia, energy security, that type of thing. So increasingly we're looking at maybe we don't need to have the data centre in downtown Sydney where we can hug the box. Regional sites are viable. There's land available and power available. And the Pulse DC guys, which are out there, they've got 100 megawatts of available power up there in Toowoomba in a very temperate environment. So it's we're going to see the rise of more of that sort of thing, which has been quite prevalent in the US, where they have regional farmland with data centres. And we're seeing some energy challenges in terms of, we've heard about a little bit about South Australia. We had a couple of not actually that hot days in February here in Sydney, and we saw ActUAGL phoning up consumers, and particularly large consumers, and saying, "How can you help us out today?" CDC came to the party, shed about 8 megawatts by firing up their gensets and doing their bit to help the greater good there. And we're seeing a lot of talk about energy security and hydro. Being a Kiwi, and I'm pretty fond of hydro, so politics aside, I think if something like this was to happen, I think it's a good thing for Australia in the long run if it was able to be got over the line. And this one here, particularly scary, there was a study done in the UK, and these guys reckoned that we could feasibly have up to 3 times energy consumption rise in the next 10 years. And that, if that happens, that's a significant thing we're going to have to deal with. I already personally have the view in Australia that our data centre energy consumption is above the 3% that's typical for global numbers, and we're trying to work that out in more detail, but I think it's probably between 3 and 4%. So we're a significant user of IT and data centre energy consumption. And many organisations coming off these fixed-term contracts, there's been a flattening in the power market a little bit in the last couple of years, but 30% price rises I'm hearing from a lot of the big operators. So let's drill down into the market a little bit more. So the ICT market. So this is the IDC data from the end of wrapped up of last year, minus 1.5% overall in the ICT market. Don't worry about that too. It's not exactly doomsday material. Minus 1.5% is not significant. If you drill into that and actually have a look at it, the bulk of that actually came from hardware, and quite specifically, within that hardware category, it was still those traditional declines, PCs, monitors, and for the first time, smartphones, they absolutely tanked, minus 15% last year in Australia. So I did personally upgrade to the iPhone 7, but that's only after getting a wave come over the front of the boat and take out the iPhone 6. So the waterproofing feature was the only compelling reason for me to upgrade. So a bit of a slowing down in that category. x86 commodity rack tower stuff was down minus 7%, and the general infrastructure category, servers, storage and things like that, was flat, all right? So if you pull apart those numbers, tell some quite interesting stories. Data centre services, that's our market for co-location and managed hosting. That grew nicely. That's the preliminary number there, 1.15 billion, 18% growth. Right, so significant growth in that particular area as it stands, and about 780 million in the colo category. Outlook for this year is a slight flattening in those numbers. There is a little bit of pockets of saturation occurring in that area, so the outlook that's being predicted is for that to drop slightly, but really continue through till 2020 being pretty strong, right? So strong revenue growth right through there. Build spend for the colo operators pretty much tracks against their revenue growth. The model is tied quite heavily to, more racks equals more power equals more space, so on and so forth. So their spend in that area tracking there. We saw quite a lot of build activity last year, and there's a lot of new projects set to kick off at the end of this year as well. 420,000 square metres of white space estimated in Australia. About 225,000 of that now sits within commercial data centre facilities, and there's about 90,000 racks that are servicing and sitting in that white space. And rack density is on the rise, right? So there's still a few of those lower density racks, but converged systems, cloud, etc., is becoming a greater proportion of the total mix inside these operators, so we're starting to see some density rise occurring. 10,000 gigawatt hours of energy estimated used in data centres in Australia last year, growing at about 5 to 10% per annum, and as I said before, energy costs on the rise. So that's the kind of summary of the clippings in the newspaper and the analyst data. So let's take a look at a little bit more research, just to give you some more granular trends, if this button decides to work. Okay, so just before Christmas, Trevor, who you just had on the stage, and Schneider embarked on a little piece of research, and we polled 450 CXO level people, and we posed them a number of questions, and the most interesting one out of that was probably, where do you see your workloads going in the next 18 months? Are they going into what's happening in your traditional on-premise space, what's happening in data centre services category, and what are you doing in terms of cloud? And these are the numbers. Minus 11% was the predicted in this group of CXOs. And just to add to that, if you've got a sample of this size, you should have statistically an error of about kind of 5%. So it should be reasonably good data. 20% growth in that data centre services category. So a lot of people looking to put more increasingly into colo. And cloud was actually quite interesting. So it was a bit of a tale of many stories in here, because if you looked at that, some of the lower down as a service offers, like infrastructure as a service, that was actually fairly flat, with people favouring those further up the stack growth rates, like platform as a service at 12.5 and software as a service at 21.6. So the overall in this sample, about 9.7% growth. Going out, now edge compute's an interesting thing, because edge compute sits underneath all of this, and I'll come into that in a little bit more detail in a moment, but edge compute in this CXO audience, 22% of them said they were actively looking at what they would need to do to combat this challenge. So IoT, a little bit of data on IoT. This one came into me just last week, actually, so I quickly put it in the deck. There was a survey done by 451 Group, and they said, first they said, how many of you are undergoing some sort of IoT initiative? And the answer was 2/3. And then they said, what's the status of that project? And you can see there on the screen that 41% already in use, 26% in pilot, and the balance of those in the next 6 to 24 months are looking to do something. The other just interesting thing in there was that the highest usage in any industry of IoT was actually the data center industry. And we've been connecting things in data centers, monitoring, measuring them and using them for neighbours ratings and controlling and things for a number of years. So that wasn't actually a surprise to me. It was nearly 60% uptake in that area of some sort of advanced IoT use. Where does that data go? I won't go into each of these bars to talk your way through them. Executive summary of this one is that a lot of that IoT data is actually being used at the edge. It's part of control. It's being manipulated there, used, and some of it is being brought back into big analytics systems, but a lot of that is being cleaned and used and at the actual edge of the network or on site with that application. This slide, I think, really shows the future and well, really where we are now and where we're likely to be heading in terms of the data center architectures. Very clever lady presented this from 451. Super smart lady, actually a Western Australian lady, Rhonda Ascerto. She presented this data at this event just in November in Paris. And she said, this is what we see happening and playing out. So essentially you've got at the top of the stack that core layer, right? So this is your big data centers, your big public cloud instances. It's the high volume, medium latency type thing that you're seeing in the US, you're seeing locally here, the big presence that these people are taking. It might be colo, it might be enterprise, the banks, etc. Sitting underneath that is this edge layer, which, as I said before, the edge layer is very broad, and edge means different things to different people. So edge to a Netflix is establishing a presence here, so we don't have to serve up all that volume of data from the US. Edge to Amazon and Microsoft might be setting up a specific cloud presence here, or putting something in a regional site, or putting something in an area where they want to target a particular market with specific security requirements. Edge could be associated with IoT gateways, and of course, really in this category here as well, fits those access nodes, and maybe we don't have the 20 rack server room in the corporate building anymore, but I can tell you we still have the 2 and 3 rack one, and they're becoming increasingly mission critical. And then at the bottom layer, we've got this device layer with the things, which obviously is a big play for Schneider, being one of the biggest producers of things in the world. So let's look at availability for a minute. So if you take that diagram I just put up with the 3 levels, and translate it into the way we look at availability, then those big top of the tree facilities are going to be tier 3 plus. Now, when I say plus, I don't mean there's no such thing as tier 3 plus, but at least tier 3, let's just call it that. Tier 3 in the regional level, and down at the edge level in the buildings, at the edge of the network, etc. Then sometimes actually, I've been conservative and said they're tier 1. All right. Reality is, to be tier 1, you've got to have dedicated power and cooling in a reasonable environment. Many of them don't, so they're probably less than that. But that's the way that that's the way those data centers and access nodes mesh together. Now, of course, if you take that, and for those of you, and it's a fairly well-informed audience, I won't spend too much time on this, but the tier 4 is the most robust, just about 5 nines, 25 minutes downtime. Most of what we see in Australia, tier 3, 1.6 hours, so on and so forth. And then we've got our access nodes and things sitting at the top, which I've conservatively said that we'll call them tier 1, but they're probably not. So the current paradigm around availability is we look at that data center, we take a disruption to IT from a single data center standpoint, and we focus on that particular thing. We look at if an IT rack went down, then that means failure. Doesn't comprehend the remote branch sites, and doesn't comprehend the people. So we put it to you that we need to shift the paradigm, and we need to start thinking about availability different. We need to start focusing on the system performance. We need to start focusing on the employees at that site in terms of numbers, but also functions. Because if the functions on that site are not particularly IT intensive, then the availability could be lower. But if it's a bank trading floor, a call centre, so on and so forth, then even an access node is absolutely mission critical. And the banks are probably leading the way in actually realising this now. They've done mass centralisation, quite a lot of cloud usage, but now we see them actually investing in their corporate buildings to actually provide highly resilient power systems within there. So analytically or mathematically, if we look at this, our current paradigm is there with the centralised data centre with our 99.98% Tier 3 availability. But if we want to look at this new paradigm, what we have to start to do is multiply the levels together. So here I've assume that we've got one big data centre through some sort of edge or access node point, and multiply that together, and we get 30 hours of downtime because we've got a Tier 1 site multiplied by a Tier 3 site. Gives us that 30 hours of downtime. Now, if perhaps that edge site wasn't as good, then you could quite easily double that number, take it to 60 hours of downtime. And if you add that up in the working year, if that downtime lands in business hours, then if you take that and put it into the number of business hours in the year, you could be looking at 3 or 4% downtime in that site. So these edge sites will become a lot more critical. So we think we need to be looking a lot more at dual resilience in terms of network connectivity. We think we need to be looking at redundancy in terms of the power and cooling in those sites. And this is not going as far as Tier 3 with concurrent maintainability. This is about bringing some redundancy in there. Planned downtime in a remote site is quite feasible, right? But we want to be able to handle a failure. So that's the kind of principle we're looking at here. And obviously some sort of decent, secure, safe environment for the stuff to go in. So the data centre weather forecast. So summarising the first sort of half of what I've been, or 2/3 of what I've been talking about. So I put it to you that there's sort of 3 weather systems out there. The first is this workload growth, right? We're finding new apps, volume of data, and it's all driving up this energy consumption. The next weather system is energy security, issues and pricing, right? So we're seeing this start to come to the fore as well. And the third is greater and greater dependence on IT, and that was touched on with Steve and the guys in the previous section. So I'm not doomsdaying here, and I'm not going to give you the George Clooney perfect storm with fishing boats tipping over and tsunamis and all this sort of thing, but I am saying that what we need to be doing is considering these systems that play out there and thinking more about them. So drilling down into our story around innovation at every level. So Joe took you through some of this stuff to start with. The bottom layer, really about the best-in-class connected products, right? All digitised. The next layer, our edge control. So this is the control layer of the data centre. This is the BMSs and the EMSs and the DSIM and things like that sitting in there, optimising, controlling and making it all hang together. And then the top layer is really the apps, analytics and services. And Kim will be talking about structure on this afternoon in one of the sessions. This is our first major foray into the really digitising this layer, predictive failure analysis, having a proper smart people sitting on the end to help you, really advanced apps and analytics and that kind of thing sitting in there. So please have a look at that either in a session or talk to the team out there. We've got representation here from our energy and sustainability people, where we're talking about your energy management strategy. We're absolutely in the energy consulting business in Australia as well, and have a great team here. Life cycle services from the initial design through to the build, maintain, perform that, and decommission. We've got an incredible services team there, and increasingly, again, we're looking to bring that life cycle services play together with that structure on play. So we think digitising more and more in that area is the way of the future. So it's about a holistic approach. Now I put a word up there as well, energy hogs. And this is not an officially Schneider sanctioned term, but it's a bit of one we use in my team. In the data centre, there is some energy hogs. There's a couple of really big consuming devices in there. And one of those is actually the inverters and rectifiers in the UPS system, and the other is the compressors in the cooling system. They're the biggest two energy consuming devices in a data center. So you'll see that a lot of our innovation and new launches and things are focused on that, and I'll give you a bit of an entree to that in a moment. So I'm going to go down now, pick a few, just 3 or 4 things that I want to talk about in here in slightly more detail. I'm going to go down into this design and architecture layer. So number 1, reference designs and our design assist with our teams. Prefabrication as a bit of an entree to Alex, who will be up next, and substantially more efficient UPS and cooling systems. So I'll take you through these 4 key points as an entree, and then this afternoon there'll be sessions that will delve down into more detail. So, talking about our engineering skills and that sort of thing, we're very lucky in Schneider to have a great team of guys in the US, an availability science team. They work with customers globally, and they're really looking at how can we make data centers more energy efficient, better, faster, leaner, all those good things. Very smart guys. They produce things called reference designs, which are not full complete designs, but they're partial designs that are then designed to be used by us in country with our customers and consulting community in the field in a design assist capacity. So we have a great team of core engineers in Australia, and we work underneath this to produce these world-leading designs. And I think this is a really critical thing. And you see this is on the web. You can put in how big the data center is, what tier rating you want, what kind of PUE you're targeting, and get dollar price points, and use it for some indicative decision-making stuff, and then use it to go down deep into more detail after that. Number 2, prefabrication. Prefabrication, when I talk about prefab, people think it's just a containerized data center and that's it. There's a whole world of prefabrication out there, and I don't think the Southern Hemisphere has traditionally embraced this as much as the Northern Hemisphere, where if you go to a place like Paris and walk around, everything's prefabricated over there, right? There's a lot of that used in modern construction and things. Here's an example. This is one of the legs of the power system of a 4 to 6 megawatt data center. So on that big skid, 13.8 meters long, you've got 2 megs of UPS, you've got your complete UPS for your mechanical system, all your switchboards, completely integrated, pre-tabled, pre-tested, in a factory, able to be delivered to site and dropped into a building. And there's a lot of the big data center operators going down this road to speed up deployment, to reduce risk on site, and that kind of thing. So prefabrication and skids there. On the left, what you see there is a 500 kilowatt or 250 kilowatt prefabricated complete power system for a data center in a module. This one's outdoor rated, unlike the other one goes in a building. This is outdoor rated. It can be used as the entire power system of a data center, just plugged in and away you go. On the right there, you see a 500 kilowatt cooling system. This is a adiabatic free cooling system, and Karthik will be talking more about this afternoon. Everything you pretty much need for cooling in a data center, prefabricated and incredible energy efficiency. Just add the ductwork, bolt it up to the side of the data center, put it on the roof, whatever. It's the whole complete system prefabricated with all the free cooling built in. These are the all-in-one modules. So this is a complete data center up to a couple of 100 kilowatts, fully self-contained. The whole thing, just drop it in, perfect for those edge site deployments that you might be looking at. And then the third thing I wanted to talk about was UPSs. So as I said earlier, there's 2 big energy hogs in the data center. There's this rectifier and inverter combination, right, where we're consuming a lot of energy. And then there's the compressor and the cooling system, which I'll touch on in a minute. So the way we work in the data center now is we take all of the energy, comes in, goes through a UPS, is converted to DC, converted back to AC, and then given out to the load, right? And there's quite a lot of losses in that process. And we've got better over time. When I started in the industry, it was very ugly efficiencies. Got a lot better. But what we want to do is we want to stop that process from occurring as much as, and still have it, but have the ability to not use it. Okay, so the old thinking in terms is to use that double conversion as the primary mode of operation. And we think in the future, this e-conversion technology that you can see actually on the floor out there running will be the way of the future. And I'll show you why. So this is the losses. These are the losses in the UPS up the side there from 0 to 12%. And when I started in this industry, the losses in the UPS were probably about 15 to 20%. And you can see from my hair, that's a while ago. By the time we get into the more modern stuff, we've got 10% losses, and that's probably been for the last 10, 15 years we've had that kind of number. And then probably 7 or 8 years ago, we got to that orange bar when we were the first actually to get to that level and get it down to 5%, right? This e-conversion process gives the full class 1 voltage, which is needed for sensitive IT equipment and data center grade protection at 1.5% losses. So incredible thing. What you have seen sometimes in the industry is that eco mode in black over there. That's 1% losses. However, that's not really data center grade. It's okay for emergency lighting and some of those more secure power applications, but not for the data center. So what does that translate into in terms of numbers? Just comparing it with the orange bar, and actually this is against the best of the orange bar offer, $10,000 per annum on a per 200 kVA of load. So if you're talking about a 1 meg UPS over 10 years, it's likely to be of the order of about $500,000, right? And all this stuff all these data and things is taken off the Energy Star websites. Just like your car, you can see energy consumption. We have to put our data to the Energy Star website, and we've just taken analysis off that site. So significant improvement there. The second energy hog, the other big one I was talking about, is the compressor. This is the thing in the refrigeration cycle and the cooling system, and that's what's generating the cool air. So right now, in the last few years, we've started to bring more free cooling in, a little bit of free cooling use. But what we want to do now is start, even in a place like Australia, there's lots of climates where we can get a lot of free cooling hours with some of the new technologies that are coming through. So the old thinking is run the compressor, and on a nice cold day, we put some free cooling in. The new thinking will be that we use the economizer more than the compressor, and we'll still have to have it. It will be unavoidable, but we will start to use that a lot less. So if you look at this graph, slightly different. If you look at a baseline as being a legacy chilled water system, a good chilled water system, chillers and cracks, for the last few years we've been doing indirect economization, putting some free cooling in. It's about 30% more efficient than the previous, than a standard chilled water system. And there's an offer that we're launching at the moment that you can see out there, and Karthik will be talking through this afternoon in the technical streams. And that's about 50% more efficient than a traditional system. So a lot of energy. This one here, I can't put some energy numbers up because every climate's a bit different. The climate for a UPS to calculate some efficiency figures is fixed, but obviously in cooling you've got to take that into consideration. So, key takeaways. Many new drivers of IT load. And we have a much more complicated hybrid data center environment to consider. So we must start to prepare for that and think about how we're going to work within that. With growing IT load, consumption of data centers has the potential to run away if we're not careful. Imagine if we really do, and I go back to Gareth's presentation this morning talking about we need to save that energy for these emerging countries that are going to have it to give their people a quality of life, right? Not just you burn it up all in data centers. So we need to really be looking as an industry, what can we do to get better here? And the last, we believe that through innovation at every level, with that holistic approach, taking the best connected products with the right controls, analytics and services and the right strategies at the top layer, that'll be the way to get the gains that we need to take us forward. Thank you.